Thank you for taking time to listen to this workshop on creating an inclusive computer science program in after school. You will learn about free resources that you can use in your after school program, including the Computer Science PD Toolkit and the other resources from Click to Science. With Click to Science, you don't need to be an expert coder or techie to lead great computer science experiences. We've broken learning about computer science down into a simple process that builds on the skills you already have. When we finish, you will be prepared to help your students develop their computer science skills right away, and you won't even need a computer to begin.
Normally, we'd introduce ourselves as presenters now, but we're going to wait a couple of minutes for that. Before we get started, there are a few things you will want to have handy as you listen to this workshop. You will need a pen or a pencil and paper to write on. And if you'd like, you can print the workshop notes handout and use that for your paper. You will also want to have a copy of the adaptations handout. And at times, you may want to pause the recording to write down some notes or to read what is on the screen. We encourage you to experience this at your own pace. If you are watching with a friend or a group of colleagues, it will be even more important to pause and take time to talk each time we ask you to think or write what you observed.
We know that young people today need to understand computational thinking and computer science to thrive in this complex world. This workshop will help you develop your own skills in supporting their understanding of computer science. And these are the objectives we'll be fulfilling today. The activities we're using come from the Computer Science PD Toolkit. In particular, we're drawing from a training called Facilitating Inclusive Learning Experiences for Computer Science. It's a 2-hour workshop that begins with an icebreaker. That's really important for setting the stage for this experience and getting everyone ready to learn about inclusion. We've adapted the icebreaker a bit for a virtual workshop. Remember, as we go through this, the goal is to get everyone thinking about inclusion. In the icebreaker, each person uses this handout to introduce themselves as they mingle in person or in a breakout room on Zoom. The challenge is to think about which of your interests you could continue to pursue if you needed a wheelchair. And others try to guess which item on your list is true, which of the 2 items on your list are true and which one is not. I came up with 3 things that I think people in a wheelchair enjoy doing. That part is true, but 2 of those things are true about my life as well. One is made up. Anne and I are going to introduce ourselves and try to guess which is the truth and which is the untruth on each other's list. Anne, why don't you introduce yourself first?
All right. My name is Ann O'Connor, and I am a project manager at the University of Nebraska at Lincoln, working with 4-H. And one of the parts of my job is working with developing resources for computer science, for this computer science toolkit. And so the 3 things that I have on my list are: I like to watch football, I like to watch basketball, I love to read.
Okay, well, I can see how all of those would be something that someone in a wheelchair would enjoy doing too. I know that you love to read, so I'm going to ignore that one. So it's between football and basketball. This is Nebraska. I think everyone likes to watch football, so I'm going to guess that you don't really like watching basketball.
That is correct.
Hey, good job for me. All right, welcome everyone. I'm Sandra Frericks. I'm a science educator for Nebraska 4-H and part of the Click to Science team. And as I brainstormed my list today, I said that I like to sing, I am in a wheelchair and I also sing in the church choir. I also love to cook, and I have a 21-year-old child who lives at home.
All right. I know you have a 21-year-old son, so that one's out. So it's between cooking and church choir, and I don't think that you sing. So I'm going to say that your two truths are that you like to cook, love to cook, and you have a 21-year-old son.
That's right. You know me pretty well. All right. So well, I'll let you go ahead and explain that icebreaker, Anna.
All right. The icebreaker gave us a chance to imagine having different life experiences and think about what we enjoy doing that would also be enjoyed by someone in a wheelchair. That is how we want to begin this learning experience for after-school program staff. We know that learners bring different points of view and life experiences to our programs. These different experiences help diverse teams be better problem solvers. Opening our thinking to consider the life experiences of others helps us work together better. Now we want to focus on applying this to computer science learning. How do you think increasing diversity would benefit the computer science field? Take a moment to write some notes about the benefits of diversity, and we will continue to add to the list throughout the workshop. Stop the video now to write your list. The diversity gap in computer science starts in elementary school. Underrepresented groups face structural and social barriers to learning computer science. After-school program leaders have an opportunity to address this inequity. We can help close the diversity gap in computer science by providing access to computer science education to all students in our programs, regardless of gender, race, abilities, or income level. All students need computer science skills included as part of the K-12 education because these skills are increasingly important in many areas of life. It is a social justice issue that not all youth have the opportunity to pursue interests and careers in computer science. Diversity is also an equity issue in the business world because businesses with diverse workforces excel in a global marketplace. These two research studies by Forbes Insights in 2011 and by Cloverpop, a business software and consulting firm, in 2017, show why business leaders are very interested in increasing the diversity of their workplace. Diverse companies and diverse teams are more creative and better at solving problems. Today, we will focus on presenting computer science learning experiences in a way that prepares all students to work in a technology-rich, diverse workplace, and how our after-school programs can give them access to new opportunities and well-paying jobs. Next, Sandra is going to introduce some free curriculum resources your program can use to address this challenge.
There are a lot of great resources online for computer science experiences, and many of them are free. Code.org and 4-H are two really good sources that we wanted to share with you. 4-H has a collection of free hands-on STEM challenges that have been developed each year since 2008, called the National Youth Science Day or the National Science Challenge. As you can see, many of the challenges are related to computer science and technology on a lot of different areas like incredible wearables and maps and apps, as well as Code Your World. You can download all of the challenges for free, and you can also order a kit of supplies for some of them. It costs about $20. Today, we're going to be featuring an activity from the 2019 National Science Challenge, Game Changers. That's the kit that's shown here in the right-hand or the left-hand side of your screen. And it's available from the 4-H shop, and you can download the print resources for free. Just Google Game Changers National Youth Science Day, and you'll come across the PDF file. We're also highlighting an unplugged activity from code.org. And an unplugged activity is a computer science learning experience that teaches you the concepts of computer science, but doesn't use a computer. You can download that activity for free as well. And there are a lot of other resources at code.org. We selected these two examples because they're great learning experiences, they're widely available, and they're free. We wanted to use examples that any out-of-school time program would be able to have access to and could try right away. The Click to Science resources that we're using today are also available for free. We're going to be using some videos that help staff and volunteers see the skill that we're focusing on in action. You'll notice that the first video explains the activity the youth are doing, and the second video focuses on the skill that we're developing, that skill of creating an inclusive learning environment. We'll start with the overview video that explains the unplugged activity called The Game Without Rules from code.org. And you'll notice the facilitator relating that activity to computational thinking or decomposition. We're not going to be exploring those areas today, but there are other Click to Science PD resources that focus on computational thinking. But as you watch this video, focus instead on how the learners play the game without rules and look for ways that the facilitator, Dagan, adapts the activity for the group of learners that he's teaching. These young people are all English language learners with a wide variety of proficiency in English. Let me switch to that video next.
Okay.
The objective of the Game Without Rules is to provide the youth an opportunity to intentionally take all 4 parts of computational thinking and apply them and get to that end goal so they can see it all together as a method. We start with decompose, so we break down the problem. And then we look at any types of patterns. Another step is abstraction, so that's taking out all of those differences and really taking a look at what might be able to be applied in different ways. And then finally, we're looking at creating algorithm. And so we're creating that algorithm, that list of steps to solve that problem. We started with an activity that was very challenging and nearly impossible in a very purposeful way.
So are you ready for a really big challenge? Yeah! All right. So you can't use paper and you can't use pencil for this challenge. You have to just use your brain, all right? Sum all of the numbers between 1 and 200 in your head. You have 30 seconds. Are you ready? Ready? All right. Think about it. Go.
And so the point of doing that is to set up that things are challenging and we need tools in order to solve them. So after the kickoff activity to get them to start seeing this, we started getting into a game that had no rules, with no instructions.
Sometimes when we are on the computer, we don't have instructions and we need to figure out what's going on. That's what we're doing. So the first part, the suggestion is to circle the sections of words that are identical from player to player.
I facilitated kind of a back and forth between the students in order to get them to start seeing that they can break down the problem.
Yeah, so first, let's see if we can find any patterns. So if we read that first sentence, take a look at that first sentence. I choose. Yeah, I choose, I choose. Is there anything else here? What's the same in these two sentences? What can I circle just like on your activity?
I have 3 orange cats and I have two orange fish.
Awesome. So our next step is underline the words that change from player to player. So out of these sentences, what's different?
2 and 3, fish and cat.
Okay, 2 and 3, and fish and cat. And then third, on this bottom part, you're going to write a script. What would a computer do in order to play this game?
So they completed that game using computational thinking and all 4 areas. At the end of that lesson, they had to write that script, that algorithm, in order to have someone else play the game with them.
We have to choose an animal first.
All right, first step, choose an animal. In my algorithm, that's what would go first, right? Choose an animal. Then what do I do?
And then you roll a dice once to know what color. To know a color. And then you roll again. And then you get a 6. You have to get, if you got a 2, you have to get a blue bow.
I'm gonna see if I can decompose. I'm gonna break it apart. There is a yellow cupcake on a tiger's tail. So that means a 2 was rolled, 4 was rolled, and a 3 was rolled. Am I right?
Yeah.
Yeah? Awesome. So I can tell, I can go backwards and forwards based on what you did. You guys are awesome. So at the end of the activity, they had the instructions that didn't exist before.
Now we've kind of got a sense for what the activity is that they're going to be doing and how that works.
Now, the second video focuses in on creating inclusive learning experiences. As you watch, think about these questions. How does Dagan make his decisions about meeting the needs of these learners? And how do these changes benefit all the learners?
Facilitating inclusive STEM learning experiences for English language learners empowers all students to engage in meaningful learning and language use with their peers. When educators are attentive and intentional in meeting the needs of English language learners, all students benefit. In the Computational Thinking with Monsters activity, I started by going over the vocabulary and provided visuals and verbal supports to help them understand what these words mean.
I made sure that I had materials in Spanish, so thankfully code.org provided those translations for us. I also just looked over the words in Spanish. I'm not a Spanish speaker, but at least I can recognize some of the cognates. During the delivery of vocabulary, I try to include total physical response, so body movements with vocabulary is super helpful for English language learners.
So decompose, we start with a big ball of something, right? It's a big problem, and then we break it into smaller pieces. Decompose.
I did the decompose, so it's a big idea to, crumble away. So that's one of those, giving the kids a mind peg or something to attach to another association is really helpful. Also, I know that I speak fast, but I was aware when I was talking fast, I'd be like, oops, I'm talking too fast. I need to slow it down and be purposeful about the vocabulary I'm using, just so that way all students are able to work in. Also, I structured the class to be in small groups. They originally had them in rows. I put them in small groups, giving all learners, regardless of English language learning status or whatever, benefit from talking to each other to process learning.
I wanted them to use their cultural assets and home language to support one another.
So you're giving her, on that last step, the algorithm, right? And you're explaining in Spanish. That's awesome. She's a good teacher, right? Yeah?
So, those are some of the strategies I used for this environment.
What did you notice in the videos? Did it give you any more ideas about the benefit of diversity to add to our list? Take a moment to add more ideas to your list of benefits of diversity. I noticed how strategies like giving a physical movement to help them understand what decompose means was something that everyone could use. It made the concept more clear for everyone, not just the students who have a limited vocabulary in English. Next, we are going to apply what we are learning to an activity called Program Your Playground from the 2019 4-H National Youth Science Day Challenge. This activity introduces the concepts of pattern recognition and abstraction. In part 1, you'll play a modified version of TAG and learn the concept of conditionals. In part 2, youth use pattern recognition to find the similarities in different versions of TAG, to figure out what makes TAG, TAG. and then use what you've figured out to create an entirely new kind of tag. But we won't get that far today. Let's look at the objectives and vocabulary of Program Your Playground. Pause for a moment and read through the first page of this activity. What do you think is most important here? Write some notes about the critical parts of the activity that every learner needs to learn or experience. Now we're going to see what the activity looks like. As I play the video, notice if the critical parts you identified are present and if every learner gets to experience them.
The Game Changers event today is about computer science. All right, does anyone know what computer science is?
In this computer science unplugged activity called Program Your Playground, Meghna, a 4-H team leader, begins by introducing fundamental concepts of computer programming, like conditional statements. To practice using conditionals, youth are tasked with designing a game of tag using the terms if and then.
Has anyone heard of a conditional before? I know we talked a little bit about this.
If food on my plate, eat. Else, don't eat.
Today we're going to use parts of the software design process to make your own unplugged games without using a computer. So we're going to create our own version of conditional tag. In this activity, I'm going to give you guys 2 beach balls, and they're going to be 2 different colors, okay? And they're going to be corresponding with different types of its. So tagging will occur with touching someone with a beach ball instead of your hand. So you're just going to tap them with the beach ball lightly. And you're going to create your own type of game similar to freeze tag. So you're going to make your own version of tag right now.
So if you are tagged by the green, it then dance 10 seconds. If you are tagged by the yellow, it then hop up and down.
I'm going to have this group go first, all right? So can you guys come up over here and explain your game to everyone?
If you get tagged by the green then you freeze for 15 seconds. If you're tagged by the yellow you freeze until someone who is not it tags you. If everyone is frozen, the game is over.
3, 2, 1, go.
Nobody can catch me. Don't get back.
Okay, everyone freeze.
After the games are played, Meghna asks youth to reflect on what was learned through user testing. She helps youth see how feedback can be used to improve their instructions.
Okay, so what went well for that?
I think that it went well because it was clear that if you were standing still, you were tagged and people knew that you were tagged.
You guys were using conditional statements, which is definitely part of computer science. You have to use that when you're coding and all that different stuff. But you just use conditional statements to make a game of tag, which has nothing to do with computers. But it still was computer science, right?
Do you have any concerns about parts of this activity that may need to be adapted? What if you had learners with special needs? Would they reach these goals? In our next exercise, you are going to need the handout called Adaptations. You will think about how the Program Your Playground activity you just attached would, or just watched, would or would not need to be adapted to support learners with specific needs. As you work through the activity, feel free to come back to this slide to read the activity or watch the video again.
As you pull out the adaptations handout, you'll notice that there are lots of special needs on the page. We don't want you to plan for all 8 of these youth in one program. Rather, we want you to think about each one as an individual and think about how you would best meet the needs of that unique individual learner in your program. When you're ready, pause and take 5 to 7 minutes to work through the handout. Keep in mind those parts of the activity that you decided were important for each child to experience, and then decide how you can make sure that they have that experience. Again, you don't have to fill in every one of the blanks. You can skip around if you want to, but be sure you come up with 2 or 3 adaptations before you return to the video. Here are the children you want to think about. Pause now and come back when you're done working through the adaptations handout. The goal of the adaptations you made were all about increasing participation. You're adapting the activity so that each learner can participate. They can experience the activity and they can achieve the important learning goals. You may have found that some adaptations would make the activity more accessible for many different students with special needs, or that some students really didn't need any adaptations at all to fully participate in this experience, even though they might have needed adaptations for a different type of activity. For instance, one participation in our training suggested shifting from a tag game where everyone was running around to a sitting game, kind of like hot potato. In that case, you could better meet the needs of several students that would struggle with running around because they had limited mobility or limited vision or didn't quite understand what was going on. But they could play a sitting down game and still observe what everyone was doing and learn from that experience and reach those learning goals that you had set. If you're watching this video with others, pause and take a moment to share your ideas about making adaptations. Now we're going to consider the long-term effects of increasing participation. As we mentioned earlier, the diversity gap in computer science starts in elementary school, when students face structural and social barriers to learning computer science. It's not just the individual who suffers, but the field of computer science as a whole. Computer science is important for the economic future of individuals and for our economy as a whole. As the diversity of teams increases, so does their chance of making better decisions. In the Clover Pop research, they found that the most diverse teams in their study made better decisions 87% of the time. To compete in a global marketplace, the whole field of computer science needs to become more diverse. The next video focuses on how some colleges and businesses are working to make the field more diverse and increase participation in their field.
A woman in dark glasses taps on a cell phone screen. Large print appears on a monitor. Words appear.
How can we include students with disabilities in computing courses? We take our smartphones, computers, and gadgets for granted. But behind all this technology is a skilled workforce of software developers, systems administrators, web developers, and programmers. There's an increasing demand for individuals who have technical skills. An understanding of computing is important for these opportunities. We often talk about broadening the participation of females as well as racial and ethnic minorities in computing courses. But what about including people with disabilities?
Richard Ladner.
Worldwide,
Professor.
there's 1 billion people.
Computer science and engineering.
About 15% of the international population have a disability,
UW.
according to the World Health Organization. So if you like, that's a lot of customers that they would like to get. And having a diverse workforce, they're more likely to have the kinds of products that will satisfy more people's needs and interests.
If you really want to explore...
Individuals with disabilities, including autism spectrum disorders, attention deficits, learning disabilities, hearing impairments, visual impairments, and mobility impairments, can succeed in computing education and computing careers.
Cynthia Bennett.
It is important for people with disabilities to pursue careers in science.
PhD student.
Because we have really unique life experiences and skills that we can offer. And it's important that for us to be stakeholders in projects and for us to be represented on the market.
Being a problem solver is definitely really important when you're a software developer.
Michael Forzano, software development engineer.
If you're someone with a disability, it's something that you have to do pretty regularly since, you know, we're faced with challenges all the time. We have to find solutions to them, so that probably makes us better problem solvers, and you know, that's definitely a good trait to have when you're working in this field.
It's very important to attract students with disabilities into computing.
Cheryl Burkstaller, director.
One reason is it's a matter of fairness. There are a lot of opportunities in those fields, and they should have an equal opportunity to pursue those fields. But another important thing is that
Accessible Technology Services.
Those fields can benefit from the perspectives of people with disabilities.
UW.
Backspace.
With proper assistive technology and accommodations, individuals with disabilities can successfully pursue education and careers in computing.
I am a software development engineer at Amazon. I work on the trade-in team, so that's the program that allows customers to trade in their old items such as textbooks, electronics like iPhones, DVDs, video games. Here I am working for Amazon as a software developer, and now I've been here almost 2 years. There's been new challenges every day that I've had to face and had to find a solution for.
My name is Jessie Schulman, and I'm an operations program manager in the web services field and a graduate of the University of Washington. And I have a learning disability, so I struggle with language to begin with, so learning a computer syntax like Java. All the problems that I had, the struggles that I had with English came up again with Java.
I am a first-year PhD student in the Human-Centered Design and Engineering Department at the University of Washington. I became interested in a career in human-centered design and engineering because I worked as a research assistant in the computer science department at the University of Washington for 2 years. I was hired because I have a psychology background and experience managing a research project.
Kevin.
I'm dyslexic, which means I have difficulty reading and
student.
Pretty bad handwriting.
The accommodations that I used in school included books on tape. I used a note taker for certain classes, and I used dictation software for my writing tasks.
I had all my textbooks in either electronic format or Braille, depending on the situation. Like for the math courses, I had them in Braille, so I could see the diagrams and everything. They bought an embosser that was capable of Brailling diagrams, so I had note takers in my classes, and you know, they would copy down the notes and the diagrams and transcribe them into Braille, which was great. You know, I had access to everything that I needed.
We started out today with 3 objectives: to understand the value of inclusiveness in computer science, to develop strategies for facilitating inclusive computer science learning experiences, and to prepare to integrate computer science into after-school programming. We've focused a lot on why inclusiveness is important and how businesses benefit from having a diverse workforce. We've also thought about how you can adapt activities for the needs of individuals within your program. Now we are going to share 5 strategies that can make all the computer science experiences you offer more inclusive. Coding clubs and robotics are growing in popularity in after school, but they are often promoted as a special opportunity for just a small number of youth. Sometimes that is because of limited resources, like the size of a computer lab or how many robotic kits you have. But sometimes it is because of implicit biases we all have about who is interested in computer science or what type of person is good at it. The truth is, there are so many different career pathways in computer science that anyone can find their niche. They may become a programmer, or a graphic designer, an analyst that works with big data sets, or a software designer that creates programs to meet the unique needs of small businesses. So, what can you do to engage diverse learners in computer science? Remember, the activity we did earlier taught some computer science content and the software design process, but didn't use any computers. We call those unplugged activities, and that is one way to be more inclusive. Here are 5 more ideas. Let's look at each of these.
You can highlight the social nature of computer science to increase interest and motivation. The social part of science, working together, learning together. It energizes learners, especially girls. Working together challenges stereotypical perceptions that jobs in computing require people to work alone in a cubicle. Facilitate computer science experiences where everyone is working in small groups and talking about their own ideas to increase participation. Make sure that discussions are respectful and that each person's contributions are valued.
Encourage creative problem solving. Learners gain confidence and trust in their own reasoning when they are encouraged to think critically. Support learners in applying their creativity, unique talents, and preferred learning styles to challenging problems. When learners encounter a problem, don't offer a solution. Instead, cultivate an environment in which asking questions, trying new ideas, and creative thinking are a regular practice. Encourage learners to ask one another when they are stuck and experiment with possible solutions to see what works.
Help all your students embrace the struggle of learning and develop perseverance. Support a growth mindset. The understanding that skills and intelligence develop through learning or through effort and learning. Emphasize that wrestling with problems and having experiments fail is a normal part of the scientific process. Provide positive feedback on things students can control, such as their effort, the strategies they try, or their behaviors. Provide specific feedback in each of these areas that develops their confidence and improves their performance. Empower all learners to embrace the struggle, overcome challenges, and increase their self-confidence in computer science and in other areas.
Provide opportunities for youth to interact and learn from role models. Use team leaders in your computer science program if you can. Introduce learners to diverse role models from different computer science career pathways and help them see potential futures. Positive relationships increase interest in computer science and help young people develop resilient STEM identities. They also help team leaders become more confident.
Make computer science real and meaningful by creating experiences that connect to the real world and draw upon the interests, knowledge, skills, culture, and lived experiences of the youth in your own program. Diverse learners, especially girls, are motivated when they feel a project is important and can make a difference. Help them see how the skills they are developing are applied in the real world to help people and improve the quality of life.
Another resource that can help you implement inclusive computer science experiences in your after-school program is a Computer Science Professional Development Toolkit that Click to Science has developed with support from the National Science Foundation. The videos we used and the activities we did together come from one of the new resources in the toolkit called Facilitating Inclusive Learning Experiences for Computer Science. You can find this resource and more at the link on your screen.
Thank you for joining us today. Ann and I are both sorry we weren't able to talk with you in person, but we encourage you to reach out and connect with us via social media or send us an email. We are happy to be a resource for you in expanding your out-of-school programming learning experiences and including participation of all young people.